Here, the function we are dealing with is quadratic in nature. So it has the form f of x equals to ax square plus bx plus c, where a is equals to 1, b is equals to minus 4, and c is equals to 5. A quadratic function typically produces a parabola when graphed, since the coefficient of x square here is plus 1. It means that this parabola opens upwards. It will be like this. So this parabola will open upwards. So domain of the function is given as 2 to infinity, which means we are interested in the behavior of the function for values of x starting from 2 to infinity towards positive infinity. To better understanding the behavior of this function, let's first rewrite it in the more convenient form by completing the square. So starting with this function, we complete the square for this quadratic expression x square minus 4x. For that, take half of the coefficient of x, which is minus 4 into half, that is minus 2, and square it. So we will get minus 2 square, which is equals to plus 4, and add and subtract this 4 inside the completing the square, that is we can write it as x square minus 4x plus 4 minus 4 plus 5. So we can write it as x square minus 4x plus 4 minus 4 plus 5. So we will get x minus 2 bracket square plus 1. So this function fx becomes x minus 2 bracket square plus 1. So this is now in the form of x minus h whole square plus k, where h is equals to 2 and k equals to 1, and this vertex form of parabola. So this is the vertex form of parabola, and it tells us the important things about the graph. Some from the vertex form, x minus 2 whole square plus 1, we know that vertex of the parabola is 2 comma 1, that is h comma t. Since the coefficient of x minus 2 square plus 1 is positive, this parabola opens upwards. So this x minus 2 whole square never has a negative value. If we substitute x as negative or positive, we will get the positive output only for x minus 2 bracket square. So the minimum value of this function fx equals to x minus 2 bracket square plus 1 at x equals to 2. If we substitute x equals to 2, so 2 minus 2 bracket square is 0 only, so it is 0 plus 1, that is 1 only. So minimum value of the function, we will write minimum value of fx occurs at x is equals to 2, which is f of 2 is equals to 1. For the values of x greater than 2, the value of fx increases because the square term x minus 2 grows larger. If we substitute x value greater than 2, then the value of this function, value of the function fx increases as the square term grows larger, because this square term increases. So therefore the function reaches a minimum value of 1, that is f of 2 equals to 1 at x equals to 2, and increases without bound as x tends to infinity. So we know that the domain is 2 to infinity, so the function is increases without bound as x tends to infinity. It is a unbounded function. So now we know that the behavior of the function. Now let's find the range. So range is set of all possible values that fx can take. So minimum value of this function is 1, which occurs at x equals to 2. As x increases beyond 2, the function value increases without bound as well. So this function takes all values greater than or equals to 1. It means that the range is starting from 1 to infinity. Because for 2, for this minimum value of the function occurs at 2. So we are getting 1 as the output for this 2. So the function takes all values greater than or equals to 1, because if we substitute input greater than 2, we are seeing that fx is increasing towards infinity. It means that value of the range is also starting from 1 to infinity. So range of the function is from 1 to infinity.